Okay, guys, this is an introductory video on complex numbers. I mean, very basic introduction, but you know what? I'm going to try and help you understand just what good they're for. Because they're really cool and they're good for a lot of things, but this is just very basic and it should give you plenty of insight as to how to put them to use. And I'm going to use it for applying it to two-dimensional rotations of things. And if you work in 3D computer graphics, complex numbers are actually used in quaternions, which quaternions use for the rotation of 3D objects and other things as well. But let's focus on just a basic complex number, and by the end of the video, I think you have a pretty good idea of what they're all about. So, in fact, it's going to be a short video. So let's look at a paint program to begin with. So what I have here is, notice here I have R for the real axis and I where you normally see the y-axis like this. All right. So what I'm doing is this is complex numbers how you typically see them. They'll have a real part and an imaginary part. They put this little letter I after the imaginary part. But when you plot it, you can just do 1, 2, 3 units over and 2 units up. And this would be 3 plus 2i, 3 units over the real axis, 2 units up in the I-axis. Okay, so it acts just like the x and y when you're plotting it in that sense. So let's say we have, let's go back to this real quick. And now we're going to put two numbers that typically you would see in uh, regular coordinates, like for instance 0.707. Typically, if you're just working in a regular unit circle with trigonometry, and you calculate this point on the circle where this is 1 right here for the unit circle, then this point at a 45-degree angle, this 45-degree angle here, theta, would give you these points x and y. But in the complex plane, we want to change this to this. So it's 0.707 on the x-axis, like this, and then it's I don't think my graphics are off, and then 0.707i in the I-axis. All right, so you have this point. It's just like that, except you add this I, and you go, well, what is that good for? Well, I'm going to show you, because what we're going to do is we're going to take this point and we're going to use complex numbers to rotate this point from here over to this location here, which is 135 degrees. All right, if we rotate all the way around. So that's still going to be these same numbers, but in normal coordinates, it's going to be just a little bit different. It's going to be minus or negative 0.707 and 0.707, how you would normally see it in regular numbers, but we'll do it as I, since we're working in the complex plane. All right, but still the same. We're going to see how we can do this rotated to this point. And normally, if you look up under Wikipedia, you can look up, you know, transformation matrices and for 2 dimensions, and you'll see the cosines and the cosines and sines that are used in order to do it. But there's advantages when you move into 3-dimensional space and use quaternions for doing rotations. And quaternions also use complex numbers. They use more than just I. They use J and K as well, but that's for a different subject. So let's go back and look at this here. So here's the form of the complex number, x plus I, y, like we said. And this, if you do anything else, nothing else, just memorize this right here. I squared is equal to minus 1, right? It's I squared is equal to minus 1. All right, so when you take, anytime you see the letter I in these equations, and if you have to multiply I times I, just remember that is equal to minus 1. That's just exactly what we're going to do to rotate this 2D point. All right, so this is just like algebra where we have two numbers here and then two numbers here. So we're just taking the cosine of 90 degrees plus I times the sine of 90 degrees. I'm going to step through this times the two numbers that we have in question, 0.707 in the real direction and 0.707i in the imaginary direction. And so we're just going to FOIL it out. All right, so we're going to do it like this. So first of all, the cosine of 90 degrees is equal to 0. All right, so you put in 90 in your calculator, hit cosine, it'll give you a 0, because that's cosine returns x when you're looking at basic trigonometry, right? And then the same thing here, the sine of 90 degrees returns 1. So the sine of 90 is 1, but in this case we have to multiply 1 times I, so there's where that I term, I'm just converting this term to 0 and this term to I, all right? And then here's the same two original numbers over here, the real and imaginary part. Now let's continue. Now that we have these like this, we basically converted the cosine and sine like that. Then, because we're rotating, basically we're rotating this point 90 degrees around the circle. We're rotating it from there to that location like that, all the way up like that. So there's your 90-degree angle right there. Okay, so that's why. So you use these terms like this, cosine of 90 plus I sine of 90. So now let's just FOIL it out. So we have 0 times 0.007, and that's going to give me this 0 term here, like this. And then we have 0 times 0.707i, and that's going to give me this 0 term right here. And then we have I times 0.707, so that sticks together with multiplication, so that's 0.707i. And then we have I times 0.707i. Well, so there's the 0.707 term, but then we have I squared, right? So I just told you I squared is equal to -1. So we can convert this to -1. So -1 times 0.707 just makes that -0.707. So what we end up with is, so that just gives us two terms. I'm just going to swap the order on these two terms. So this becomes, this is -0.707, so it's -0.707 plus 0.707. So what I have is the real term here, because this is complex, and then this, oops, is I. This term is this term here. So I just swapped the order of these because this is the format. There's your real part and there's your imaginary part. So we have -7.707 and positive I. So if we go back and look at the point, so it becomes, there's -0.707 and there's a positive 0.707i. So we've effectively rotated this thing 90 degrees around the circle like that just by using this rotation, just by using cosine and sine of 90, I sine 90. In fact, if you ever notice Euler's formula, for those of you familiar with it, it's just e to the I theta, like this, plus 1 equals 0. So we'll look at that at another time. But this I theta is, sometimes people put it as theta I, is really just saying cosine of theta plus I times the sine of theta. Right, so just remember that every time. Cosine of theta plus I times the sine of theta. I could put my parentheses, but I don't know if I can do it with my mouse like that. So if you do nothing else, remember cosine theta plus I sine theta. I always remember it as I sine, like I sine a document. Cosine theta plus I sine theta. Cosine theta plus I sine theta. And then remember this, I squared is equal to -1. And then try it on your own points. Just make sure you set your points with I for the imaginary axis. And then you can multiply it. You can substitute these. You can put in 20 degrees and then calculate that first and then FOIL it out and you'll get your new point in 2D. It's that simple. Okay, well, that's it for this lesson, and I'll see you in the next lesson.